Hello, everybody, and welcome to the first video in the Learning Exploration series of the Artificial Intelligence in the Liberal Arts Initiative. This video will be on prompt engineering and leveraging prompt patterns to get the most out of your AI chatbots, such as ChatGPT, Bard, and Microsoft Copilot. And my name is Chen, and I am part of the tools and mentorship team of the Artificial Intelligence and Liberal Arts Initiative. So first, a little introduction of who we are, since this is the first part of the series. It's part of the AI Learning Exploration series, which is presented by the tools and mentorship team of the AI in the Liberal Arts Initiative, or AILA. The mission of AILA is to facilitate community engagement, education, and awareness in the interactions between artificial intelligence and other topics in the liberal arts, such as history, journalism, English, music, and other aspects of the sciences, such as life sciences. And our goal as the tools and mentorship team is to educate communities on the usage and consequences of AI, ranging from the implementation of AI tools and code to discussions about the social impacts. So first, before we dive into some prompt engineering, I think it will be very useful to go over what large language models such as ChatGPT actually do under the hood at a very, very high level. So we won't go over too much about it, too in depth about the computational aspects. But essentially what it does is it takes a prompt and the previous words that it generates and calculates the probability of the next word being the next word. And it goes one word at a time. So given the text that it generates so far, it asks itself, what should the next word be? As we can see here, if we have a text called "the best thing about AI is its ability to," it will generate a probability distribution of the next word. So it appears that the highest probability is to learn, which is a 4.5%. So these are all valid options for what the next word could be. However, the highest probability word is usually not picked. There is an element of randomness to the next word it selects. And this is an intentional choice, because if we think about it, if we only select the highest probability word, what happens is that our output will, in general, be bland. It will be very predictable and kind of boring, for lack of a better word. If we add an element of randomness to it and do a little more computation, we'll be able to have like more creative answers and more substantial outputs. So in this case, the next word in this statement doesn't have to be learn. It could be either one of the other four words or none of these at all. It really depends on what the previous words are and what our prompt is. And this is why we need some extra skill in prompting in order to make sure we have some creativity in our answers and to ensure that our model is selecting the best word that we want each time. So an overview of prompt engineering. First, what is a prompt? And a prompt is a set of instructions given to a model that programs the model by customizing it and or enhancing its capabilities. So some general guidelines for prompting is to be as specific and detailed as possible about its structure, a structure relating to the context of what we are asking, the format of its output, and the length of its output. One thing I will say is that you shouldn't over-engineer too much, especially in the context part. If you give it too much information, that will sort of confuse it. And so we really want to, if you really want the most out of an output that you want, specifying the structure of the output will yield the most substantial results that we will want. Next, you should give it some positive instructions instead of negative instructions. In other words, tell the model what to do rather than what not to do. Again, because there's an element of randomness to the outputs it generates, as we mentioned here, we shouldn't be afraid to keep repeating generations to plug in the prompt again and to edit prompts slightly. By doing this, we'll be able to get a vast array of different outputs that we can sort of combine together and allows us more agency in choosing the best output that we want. However, we can only do this if we take the time to really go through each generation and prompt and keep repeating and experimenting. Finally, models learn from our inputs and prompts. For instance, we can give it information and it will keep that information for future use if we allow it to. However, this is lost when you start a new chat. If you've probably used ChatGPT before or any other model, you'll know that you have the option of starting a new chat or conversation. This erases all the data from your previous chats, or it keeps the data in the previous chats, but none of that data transfers over to your new chat. So to maintain previous knowledge, you should stay on the same chat and only create a new one when you want to reset the conversation or start something new. What this video will mainly go over is the prompt pattern. There are other aspects of prompt engineering, but I believe that the prompt pattern is probably the most useful as well as the most general that can be applied to many different usages. So prompt patterns are prompts that guide models for specific tasks, and they're usually defined by core contextual statements. Prompt patterns will follow these 4 guidelines, and these guidelines are important in order to standardize their purposes. So first, you have the name and classification, in which most prompt patterns, they have their name and they're classified under different categories based on how they are used. There's the intent and context of the pattern, where we describe the problem the pattern is trying to solve and the goals that it wants to achieve. The motivation describes the purpose of the problem itself and why it's important to solve the problem. So in this case, intent and motivation are kind of 2 different aspects of the problem, in which intent, we're trying to describe the problem itself, and the motivation is describing of the purpose of the problem. Finally, and this is the most important aspect of the prompt pattern and where the patterns get most of their power, it is the structure of the prompt. And each prompt has a specific structure that they follow. And this is where the core contextual statements come in. Each structure and each prompt pattern is defined by these statements. And it's really what differentiates the patterns and the outputs. So if you're smart enough or clever enough to come up with your own prompt pattern, you should follow these guidelines in order to document your pattern and facilitate using it in the future. And this is why it's important to standardize these prompts, because each of the prompt patterns I will go over in this video will have these 4 aspects that will help in our consideration of whether to use it or not. So let's get into more of the categories of prompt patterns that were mentioned in the name and classification aspect of each prompt pattern. First, we have input semantics, which is teaching the model to recognize certain aspects of our inputs. There's output customization, which is restricting and tailoring the format, structure, or other properties of the output. There's error identification, which allows the model to help us check for errors. This is useful because, as we may know or may heard, most models, they can give inaccurate information sometimes. So it'll be useful to have this. There's prompt improvement, in which you can actually use the model to provide you with better prompts. There's interaction, in which we change the conventional interaction between the model and us with something new. For instance, instead of us giving them a prompt, as we typically see it, it could be the model asking us questions or the model prompting us to enter some type of information. Finally, there is context control, in which we provide the model with contextual information that changes the way the model operates. So the first prompt pattern that I'm going to go over is the meta language creation pattern. It is part of the input semantics classification, and its intent is to allow the user to declare an alternate language or input for the large language model, so that we may write future prompts using this new language and its semantics. The motivation is that many problems have words or ideas that could be expressed concisely with shorthand notation, allowing it to be communicated more efficiently. So structures, when I say X, I mean Y. So as an example, I'm going to give a little bit of contextual information here. But graph theory is a very important aspect of mathematics in which we have, a graph can be two objects connected by an edge or multiple objects connected by several edges. So in this case, these are just two objects connected to each other. That's essentially what a graph is. And graph theory is a very, very important part of mathematics, and it continues to be studied. It's a very huge area of study today. So, as an example, if we want to ask a chatbot a problem on graph theory, it's kind of tedious to go over this is an object, or this is an edge, or this is an edge connecting everything. So what we can do is we can use meta language creation. By the way, for all these examples, I am going to use Microsoft Copilot. The reason being that a little pro tip is that it has three options: more creative, more balanced, more precise. More creative and more precise, use ChatGPT, use GPT-4 for free. So you don't have to pay for it, which is very nice. So as an example, say we want to do a problem in graph theory, I can say from now on, whenever I type two letters separated by a greater than symbol, I am describing graph. For example, a greater sign B is a graph in which nodes A and B are connected by an edge. As we can see, if we use the creative option, they will give us other suggestions, which is very nice. So I'm going to do A, B. And then if I do BC, this will add a node to it looks like we're not getting the graph. Very a little bit trouble here. Usually it displays a graph, but it looks like So here we go. Yeah. Usually it actually gives us a visual representation of the graph, but we're having a little bit of trouble now. But essentially, if we get the idea, we're able to use very shorthand notation to create our own environments. So instead of writing, please have a graph with the node from B to C, we can use this shorthand notation in order to create our to create what we want. Next, we have the persona pattern. Its classification is output customization, and its intent is to give the model a persona or a character to help it select an output and focus on what details that it uses. So often users would like the model to take a certain point of view that will allow it to give more insightful outputs. So the structure could be to act as a persona X and to create outputs that persona X would create. Actually, go to Microsoft Edge. Yes. So actually, apologies for the previous hiccups, but if I go to Microsoft Edge, I am able to actually do the input semantics again in the language creation. So again, we have the graph separated by A and B and by an edge. So if I type A, B, it will give us a new graph, hopefully. Yes, okay. So here, two objects, A and B, and it will even generate us an image of A and B, of a graph representing A and B. So if we do C, B, C. Yes, and it will add C to the node where C is connected to B. It's okay if this is a little bit confusing, but essentially the main gist is that for complex environments like graph theory or other topics that you may want to explore, it is very easy to actually create a new sort of language or shorthand notation that you're able to teach to your model. All right. So if we go back to the persona pattern, try to get an example of that. For example, we can give our model a professional role. So I don't know, let's say we want to make it a speech pathologist. So act as a speech pathologist. And what we can do is maybe we can ask it to provide us an assessment that a speech pathologist would. So provide speech, some gibberish. And here it is giving us a very nice summary that from the perspective of a speech pathologist. And what, as we can see, Copilot has this neat thing where it can actually search the web, and it can get stuff from the web, and it provides its sources. It even goes over the articulation and many other aspects that a professional speech pathologist might go over. So yeah, so again, the main purpose of this is to really give the model a persona. And when we do that, the model can take a certain point of view that will allow it to give more insightful outputs. Maybe I can do another example where I can ask it to act as a 9-year-old skeptic. What is your some silly thing like that, and maybe it'll give us a something a 9-year-old would say. I don't think this is exactly what a 9-year-old would say, but maybe we do some other engineering, we could get it to be a little bit more accurate. Okay. So moving on, up next is the infinite generation pattern. This classification is output customization, and its intent is to automatically generate a series of outputs without having to re-enter the prompt each time. And the motivation is that many problems are complex and will require multiple different attempts in order to get a satisfactory answer. So continuous generation of answers will help automate this process. So the structure is I would like you to continue to generate an output forever, or X outputs at a time, or once I tell you to stop. For example, maybe you are indecisive and you can't figure out what quite to eat, or maybe what to watch. So maybe I can ask it, recommend me some watch. Continue generating answers until I tell you to stop. It did not quite do that, but I did try it with another example of maybe some names of people, and it doesn't infinitely generate them. But what it does do is it asks if we want to generate more, and we can simply just say yes instead of having to repeat the prompt, and it will continue generating things for us. So I think this goes back to what we said about I would like you to generate an output forever, maybe X outputs at a time. So the next pattern is the question refinement pattern. This is part of the prompt. This is our first prompt improvement prompt pattern, and its intent is to have the model suggest better and more refined questions that it may arrive at a better answer. So the motivation is that people using the model for a specific topic are likely not to be experts on that topic. So we may want to use the model to provide us with the tools necessary to fill in our knowledge gaps and come up with better prompts. So the structure could be from now on, when I ask a question about X, suggest a better version of the question that I can use. So suppose I want to ask about maybe internet security. So I ask from now on, whenever I ask a question about the internet network security, suggest a better version of the question that incorporates security risks in the network, and then you should specify to if you would like to use the model's question instead. It agrees. So let's say, what are some potential security risks of the IPv4 protocol? And as we can see, it is providing us better versions of the question that are much more specific, and will allow you to get a more specific answer without it being too general. And as you can see, it mentions some cryptography and authentication of the IPv4. So some stuff that we might not be familiar with. And yeah, it's a really good way to really fill in some stuff you might not have thought about before. So up next, we got the fact check list pattern, which is part of error identification. I went over this before, but again, the intent is to have the model output a list of facts that need to be verified. And this allows the user to pinpoint concepts in the output in order to fact check them manually. And motivation is that it is well known that models will sometimes output information that is convincing yet factually is incorrect. And although there's no way to change this from the inside of the model, we may want to leverage the model to help us verify the facts. So from now on, we may want to generate a set of facts based on each output, and the facts should be fundamental concepts pertaining to the topic of the output that could undermine its veracity. So for example, say you're studying for a biology exam and you want to know more about metabolism. You may want to, but however, you may not trust the chatbot completely to give you the most accurate information. What you can do is say, from now on, whenever you generate an answer, provide a set of facts the answer depends on that should be fact checked, and display them at the end of the output. And if you want to make the this fact check list a little bit more condensed, you can only ask it to display facts related to a certain topic. And Copilot even assures you that it's a great way to verify the accuracy and reliability of the information. So let's say this. So let's say how the as you can see, it gives us this rather high level, not too detailed explanation, but it will give us the facts, some very important facts, such as ATP synthesis and how our energy is converted into different submolecular levels. And in fact, in this case, actually in Copilot, since Copilot does implement web searching, so maybe you don't even have to, this prompt pattern where we verify facts is actually kind of built into Copilot, because we have these, it does cite its sources that it uses. However, when you use something like ChatGPT, which does not have, especially 3.5, which does not have web searching implemented, this skill and this implementation of a fact checklist may be very useful. Next, we have the output automator pattern. You can go back and look at the classification of it, but essentially it is whenever an output takes multiple steps to produce, we may want to automate those steps so that we may speed up the process in the future. And we can say from now on, if an output has certain properties like X, we should automate the process X. And from the rest of these patterns, I will actually leave it to you to decide what the intent and motivation is. And maybe a good exercise for when you're using these prompt patterns. So for example, let's say we are actually coding. We can ask our model to, from now on, whenever you generate Python code, create a separate text file that contains all imported libraries that are used. And it will understand this. It will actually tell you that it's a great way to keep track of dependencies and requirements of our code. So I asked it to write a Python script that performs matrix multiplication, which it does. And in this case, it may not be the best example because there are no dependencies that this relies on. But it does give us the text file that of all the imported libraries that are used in the code. And in this case, there are none. But typically, we can perform many of these computational tasks in Python using libraries such as NumPy and Pandas. And in this case, those would be put into this code. So if you're too lazy to actually keep importing statements into code, you can just have a text file outputted by your model that will provide you with the necessary import statements. So again, this is part of the output automator pattern. So if you have a task that you want to just have automatically done and is able to be automatically done, you can just tell the model to automate the process. Next is the alternative approaches pattern, another prompt improvement pattern. And the structure is to have the model offer alternative methods of completing the task if a better method exists. So from now on, if there are alternative ways to achieve X, List the best alternate approaches and compare them. Actually, a lot of models kind of already do this. I think there may have been another example previously where it gave us some better options as to um, what what methods of it was about the graph theory, I believe, and it asked us what there are probably better ways to represent graphs. So as an example of the alternative approaches pattern, I asked it to, from now on, whenever I provide you with a task, if there are better ways to perform the task, list the best alternative methods at the end of the output, which it agrees on. I have noticed that the Copilot does like kind of reiterate a lot of the benefits of these prompt patterns, which is very nice. So I asked it to sort this array using from least to highest number using this sorting method called bubble sort. You don't have to like know what these are. Just know that bubble sort is a very slow sorting method. So it will probably give us some alternative approaches. It provides us with code for bubble sort. It gives us the correct sorted array from the lowest to highest number. And then at the end, it does give us with some alternative methods to sort the array, such as selection sort, insertion sort, merge sort, quick sort. These are all actually are known to be faster than bubble sort. So yeah, this is just a very trivial example of how we can use the models for using different approaches, especially when we don't know what these approaches are. In this case, I kind of knew in this example, but if you don't know, you can always just tack on a little, give me a list of alternative approaches at the end of each of your prompts, and maybe you'll learn something or get more insight. Up next is the cognitive verifier pattern, another prompt improvement pattern, which is, and the structure is when you are asked a question to generate X additional questions, that will help you generate a more accurate answer if needed. And when you've answered all the questions, combine my answers to give a complete answer to the original question. I won't go over, I actually won't go over too much of an example with this one because some of the examples are very, very specific and you'll need a very, very specific topic in order to do this one. Finally, we have the visualization generator pattern. It is another output customization category. And its structure simply is to generate a prompt X that I can use on tool Y to generate Z. So for an example, if you can generate, for example, maybe you want to plug in a prompt into DALL-E, which is our art generator. So maybe we can generate a prompt that I can use on DALL-E to generate some sort of picture that we want. So for example, I asked it to generate a prompt that I can use on DALL-E 2 to generate a picture of typical spring scenery. And it does, it gives us this rather detailed prompt. And if we plug this in to DALL-E, we can see what we are trying to get here. We want to generate it. The reason why this is actually useful is because since many of these models are actually very similar to each other and work in very similar ways, the models kind of sort of, they know what prompts can work. And so since the AI models are they're more standardized than like people, the prompts can be very useful when they're used across different AI tools. And here they do generate some of wide variety of different sceneries for us. Okay. So that was all the prompt patterns that I want to go over. If you want further in-depth information on prompt patterns, many of these prompt patterns and examples are from this paper, a prompt pattern catalog to enhance prompt engineering with ChatGPT from the Department of Computer Science at Vanderbilt. If you want further reading and more in-depth content into these prompt patterns, you can look at this paper. But otherwise, that's it from me. I hope you learned a lot about prompt patterns and hope that they are very useful to you when you are working with prompts and using ChatGPT and other models for your own work. So thank you, and yeah, happy prompting.